So let's find the inverse of a function that is actually an equation and not just coordinate pairs. And then we're going to figure out how to graph both the function and its inverse. So we talked in the last video about that inverses are just found by switching the x and y coordinates. So we're going to do that same process. Even though this is an equation, we're going to go ahead and switch. So the very first thing to do when finding an inverse of a function is to change the f of x, just change it to y. Let's just get it nice and streamlined to have both an x and a y showing. So f of x becomes y. First step there. Second step, interchange the x and y, because that's what we've said is the way to find the inverse is to just switch the x and y. So first get the f of x off of there, and then switch x and y just right where they are. So there's the second step. Now we're going to actually solve for y. So in order to get y alone on this one, I'm going to have to square both sides. So again, the third step is solving for y. Here we go. We have x squared. And so now we have y plus 2 is now available to manipulate since it's out of the radical. So now I can go ahead and get the y alone, and I get this, that y is equal to x squared minus 2. Now the last step in in finding an inverse is to go ahead and replace the y with the inverse, oops, almost forgot that part, the inverse representation, because we've found the inverse and we need to note that it is the inverse function. Okay, it is indeed a function, and because this was indeed invertible, it was 1 to 1. Okay, so again, that means that the inverse is also going to be a function. So now we want to graph both of these on the coordinate plane. What is going to happen when we get these two on the coordinate plane is that these two pictures are going to be a reflection in the line y equals x. So I'm going to go ahead and put a dashed line through the y equals x line. This is y equals x. Now think about it, think logically. If I find the inverse by switching x and y, then it makes sense that the two pictures would be reflections in a line that is just x and y being the same. So let's go ahead and put this first one, the square root of x plus 2. Alright, so I'm just going to make a quick little table here. And I'm going to start with negative 2 because that's going to give me a nice neat little 0 answer. I'm going to put in a negative 1 into this function, and I'm going to get out a 1. Square root of 1 is 1. Now I'm going to skip 0 because if I put in a 0, I'll get some irrational number, right? 0 is going to make that under the radical is going to be a 2, and I don't want that. So I'm going to put in a nice neat little 2, which is going to give me 4 under the radical, which is 2. So let me go ahead and get those points on, and we'll get that sketch. Negative 2, 0, right there. Negative 1, up 1, and then over 2, up 2. So we know that the parent graph is doing this, right? So we're just needing to confirm that this is just a movement to the left 2 of the parent graph, right? So there is the the adjusted graph, okay, of the parent square root function. So now we're saying that this inverse should be a reflection, right, in this axis. So it should look something like that. So I'm going to take those back out of there. Okay, so now let's go ahead and graph this one right here. So I'm going to go ahead and give myself a table of values, and you notice the domain on this one could be anything. I didn't just have to start at negative 2 or greater. So I'm going to go ahead and put in negative 2. That gives me a 4 minus 2 is 2. I'm going to put in a negative 1. That gives me a negative 1. I'm going to put in 0. That gives me negative 2. Put in 1. Gives me negative 1. And then if I put in a 2, I'm going to get a 2. So let's go ahead and put these points on. Negative 2, negative 2. Oh, excuse me, negative 2, 2. There's that. Oh, Isabel. Negative 1, negative 1. Something's looking fishy here. Over 0, negative 2. Over 1, negative 1. Okay, something. Let me double check my little numbers here. Negative 2, that's going to be 4 minus 2 is 2. That's good. Put in negative 1. I get a 1 minus 2 is negative 1. Good. Oh gosh, I'm fine. We're doing fine. Okay, over 1, negative 1. Oh my gosh, I couldn't even recognize a parabola when I saw one. Okay, so then there's that. Alright, so what's happening here is this. I've got half of a parabola. Now, why is it that I can't put these other numbers here? I'm actually having to take these out. Why is it that I could not put those values in there? Because this situation was limited to greater than negative 2, right, for my input, and so guess what has to happen? When I invert this, I can't have any values less than negative 2 on the y values. Okay, so I'm not able to have those other points part of my function. So again, this inverse is indeed a function, okay, because we have to limit. We have to say that our values have to be greater than or equal to negative 2. Okay, so in essence what we're saying is the domain of the inverse has to be in the range of the function. The domain of the inverse has to be in the range of the function. So that's why we're saying that only negative 2 and greater can work there. Okay, so I hope this was helpful, and thanks for